Welcome to our eye-opening examination of renewable energy, beneath its green veneer. This video, The Renewable Energy Myth, Why It's Not As Clean As You Think, is a deep dive into the lesser-known aspects of renewable resources. We're going to peel back the layers of the clean energy illusion, looking at how renewable technologies are made and installed, the limitations they face and the impacts they have on both our planet and society. Join us as we dissect the complexities of the renewable energy sector and uncover the hidden truths. 1. The illusion of clean energy. The notion of renewable energy as our savior from environmental doom is captivating yet misleading. Many people imagine fields of wind turbines and solar panels generating clean electricity with no downside. This vision, however, ignores the complex reality behind so-called clean energy. Yes, renewable energy sources like wind, solar, and hydroelectric power do provide alternatives to fossil fuels and can significantly reduce carbon emissions when in operation. But it's crucial to remember, clean energy is not synonymous with absolutely perfect or free of environmental impact. The process of manufacturing, transporting, and maintaining these technologies often involves the use of resources and results in environmental consequences that are sometimes overlooked. 2. Manufacturing renewable technology. One critical aspect of renewable technology often glossed over is its manufacturing process. Building solar panels and wind turbines demands raw materials like silicon, rare earth metals, and large amounts of water. Mining these materials can be glaringly environmentally damaging, leading to habitat destruction, soil erosion, and water contamination. The energy-intensive production of these technologies also results in greenhouse gas emissions. Although these emissions are significantly lower than those from fossil fuel production, they negate a part of the clean label that renewable energy possesses. Moreover, the transport of materials and finished products adds another layer of environmental cost. 3. Installation and land use concerns. The transition to renewable energy also comes with significant land use considerations. Large solar farms and wind installations require vast areas of land, potentially disrupting ecosystems and existing land use patterns. Think of wind farms that span thousands of acres or solar installations that stretch across fields once used for agriculture or grazing. This substantial land conversion can have profound effects on local wildlife and biodiversity. While it's true that renewable installations can coexist with agriculture in some cases, not every piece of land is suitable, which leads to conflicts that we must navigate cautiously. The indirect environmental impacts, including the disruption of local fauna, need to be weighed in the balance when considering the bigger picture. 4. Resource scarcity and material limitations. A lesser-known fact about renewable energy technology is its dependence on scarce resources. Truly clean energy is often stymied by the scarcity of crucial materials. Rare earth metals, essential for wind turbines and electric vehicle batteries, are limited. Obtaining and processing these materials has a significant environmental footprint. For example, the mining industry in places like China has faced criticism for their detrimental environmental practices and human rights issues. Therefore, as demand for these materials increases, so too do the challenges associated with procuring them sustainably. As we strive to meet our energy needs, we are left with the dilemma of balancing resource extraction with sustainable practices. 5. The issue of energy storage. Renewable energy presents a unique problem with energy storage. Intermittency, the fact that the sun doesn't always shine and the wind doesn't always blow, makes consistent energy delivery tricky. To counteract this issue, effective energy storage solutions are required, typically via batteries. Current battery technology is laudable but not flawless, relying heavily on lithium and other finite resources. As these batteries reach the end of their lifespan, disposal becomes a concern due to potential soil and water contamination. The production process of batteries itself also involves significant carbon emissions. Without efficient energy storage, the reliability of renewable energy remains a significant challenge. 6. Lifecycle emissions and waste. While renewables drastically cut operational emissions, lifecycle emissions tell another story. Every product has a life cycle, and renewable technology is no different. From the cradle to the grave, every stage, from extraction, manufacturing, constructing, operating, and decommissioning, accumulates emissions. At a first glance, solar panels and wind turbines might appear emission-free, but their lifespan reveals contributions to atmospheric greenhouse gases. Moreover, managing end-of-life disposal for these technologies is an emerging issue. For instance, while solar panels have a lifespan of around 25–30 years, disposing of or recycling them poses significant challenges. This disposal process creates waste that can often end up in landfills, leading to long-term environmental impact. 7. The financial and economic equation. Switching to renewable energy isn't just an environmental consideration, there's also an economic factor at play. Building and maintaining renewable energy infrastructures is a costly endeavor. The initial investment required for developing these technologies can be prohibitive, especially for developing nations. Additionally, the subsidies required to support renewable initiatives can place a strain on national funds. Economic growth, energy security, and social acceptance are intertwined in complex ways, making a seamless transition to 100% renewable energy economically challenging. It's vital for policymakers to consider the financial equations and ensure that advancements in energy technologies align with broader economic goals. 8. The human element behind every wind turbine or solar panel are human beings and communities impacted by renewables. Human considerations often go underreported in favor of the "save the planet" narrative. Indigenous lands can be encroached upon, and communities can be displaced to make room for massive installations. The working conditions in the mines extracting key materials often involve human rights violations. Integrating social equity and community involvement into the renewable energy discussion can ensure benefits aren't limited to wealthy nations or individuals. Understanding and respecting the human element in the renewable transition is as crucial as reducing emissions. 9. Balancing act. Striving for sustainable energy. Despite these concerns, renewable energy remains one of the best solutions available to prepare for a sustainable future. However, recognizing the complexity of the energy landscape helps in making informed decisions. It's not enough to replace one form of energy production with another without considering the broader implications. The challenges discussed here invite a balanced and comprehensive approach to energy policy. Finding ways to improve manufacturing efficiencies, minimize land use, and develop robust recycling programs will enhance the credentials of renewable energy as a truly sustainable solution. Humans have always thrived under challenges. Perhaps the way we tackle these renewable energy myths will pave the road to genuine progress.